Hello folks, my name is Brian Kirsch. I'm an instructor at MATC, and I wanted to kind of talk about today a Synology NAS, and specifically external storage and what we're doing with it. And I want to start today's video with the hardware aspect. So I've got two different camera angles just so you can see the device itself. This is a 8-bay Synology device. It's a little bit older unit, but for our purposes, it's going to work really well. So let's talk a little bit about the reason why you use Synology, a device or something like this. These things are used because you have more storage than what you could physically typically fit inside a computer. So this way you can add, 10 terabytes, 20 terabytes, whatever you need to do, and you're not constrained within the same framework, okay? This unit has 8 drive bays in it. The numbers are out of order, but don't worry about it. The actual drive slots are empty. So what I actually have to do, and while I'm talking, I'll be doing it, is I actually have to put the drives in. So I've got several older drives that I'm going to basically mount and then put into the Synology. And I'm doing this just to kind of show why you can do this and where the benefit is. A lot of times, when we look at external storage, we're either sharing the data or we're looking at storage where we have more than what we can physically have in that one desktop. The Synology works great, and there's other vendors as well. I don't want to just, point this out as a single vendor video, but these external storage frames give you exactly that. External storage that is continually always running. When you look at a device like this, it's similar to a computer. It's got a processor, it's got RAM, but the difference is it does one thing. It does one function. And when you look at that, you can have a much smaller CPU. You're talking about something that might be a dual core, maybe a gig and a half. You're not talking about anything that's got high speed. That's because it's not doing a ton. You're doing file system processes. You're handing out files at the end of the day. That is a big deal. That means you can have these things be extremely low power. So yet they contain spinning drives, and it's pretty easy just to mount a drive as you see, and then you basically slide it in and kind of set it and away you go. So it's very easy to do, but these things can easily have 40, 50 terabytes of data, not gigs, terabytes. And because of that, you can have massive storage. Now, you might be kind of wondering, well, why would I use this? Why wouldn't I use SSD? It's more power efficient. All those topics come up. One thing you got to remember about data, and this is such a critical aspect, is a lot of data is unfortunately dead data. And what I mean by that is it's data we need to keep, but it's not data that is typically accessed. It's not data that is something you're going back to. You have it more for archive, you have it for a reason, to keep, like your old taxes. Something you hope you never go back to, but if you need it, you obviously need it and you need it right away. That's what a lot of our data is. And so to, put SSD in here or NVMe or anything else is expensive. You're spending a lot of money on high-speed data, high-speed access to data that, to be honest, do you really need? Most likely not, So, another drive in. So that's kind of why we still use spinning disk. But that also underscores the point of data itself. We need it. We need different ways to store it. We don't want to just put it in one giant desktop. Here's the other thing. These things, in like this particular model, basically runs what's most likely a reduced version of Linux. That way then it does really one job. It's got one job to hand out files. Now, these devices have, you can make an FTP server out of them, a few other things, because there is a processor in there, and a lot of these devices have an app store where you can download additional things for either free or a small fee. But for the most part, people use them for storage. That's what you do. The great thing about this, and what I'll do is I'll explain a little bit on the hardware side of it. These things are basically a NAS, network attached storage. So they have an Ethernet port, 1 or 2 out the back, and they connect to your Ethernet network. Meaning, this is basically becomes a shared drive letter on your network. That's a pretty easy thing to do. Well, once it's a shared drive, you can simply access it like a drive letter. Well, that's a big deal, okay? And being able to do that, you can access it multiple machines within your house. You can access it, multiple machines within a network, anything like that. Well, that gives you access, shared access without the need of a computer. This could be put in a closet or something where you have minimal airflow and, let it run for, to be honest, for years. And because of that, these things work really well. Economical, and this is an 8-bay unit, so that's what I'm working with right now today. They go anywhere from 2 to 8 bays. So a 2-bay unit, you could do it as a RAID 1 or a RAID 0, which, a mirror or a stripe, depending if you want performance or obviously data protection. This unit here can do RAID 5, RAID 6, because it's a little bit bigger, more drive types, and it even supports multiple RAID groups, which is a big deal. So because of that, I have flexibility. And that's a big deal when it comes to storage. I might need a RAID 1 for a certain part of an application and a RAID 0 for logging or something. It just depends, and that's because it depends on what my application is. And with that being said, helps to put the drive in the right way. My apologies. Because of that, you have ultimate flexibility, which is just absolutely so key. These units can range anywhere from under $200 to easily over $1,000, and obviously when you get into the professional side of the thing, enterprise grade, into the millions of dollars. But the great thing is, it starts out at a budget-friendly price. Now, a lot of people use these for home, small offices, things like that, and they work tremendously well. And again, it's about kind of the bang for the buck here and making sure that you get what you need for your particular application. Now, these type of devices typically do not have redundant power supplies. So unlike an enterprise solution, you have one power supply, so if it goes, you could be in a little bit of trouble. But they do typically support the RAID 5, where you can do a hot swap of the drives. They also support typically dual network connections. So in the event you lose a network or a switch, you have the protection. Now, as I continue to populate this device, there is an OS on here. Again, I mentioned it, it's most likely a modified type Linux OS or something similar. That is actually contained on the drives. In this model, typically it's going to be on the first 2 drives in the system. Other models and other vendors in that, it could be on up to the first 5 drives. With that being said, when you first discover it, and that'll be in the next video, it'll actually install the operating system on its initial drives. So it'll wipe the drives, install the OS, kind of, and away you go. It's basically, if you're doing 2 drives, it's most likely a mirror of the operating system for the Synology in this case, or the storage frame, depending on your vendor. That's because in the event you lose a drive, you don't want to lose the storage, operating system. So that's kind of why you do it. It's pretty easy. It's pretty, one, it's robust, but it's also lightweight. There's nothing here that's going to be massive or heavy. These things are designed to be efficient. They're designed to be, you know, quick, robust, relatively inexpensive, and you know, fairly easy to use. Nobody is making these things be overly complex, because that's just a problem, and nobody's going to use them. Now, as you see all these drives I'm putting in, the first 6, and again, my apologies, the numbers are out of order. The first 6 were 4 terabyte drives, and the last 2 are going to be 2 3 terabyte drives. And this just happens to be what I had, you know, extra drives kind of laying around. Now, the benefit or with this is most of these types of devices can deal with that. And they'll create a RAID group, let's say a RAID 5, with the drives that I provided to it. Some people call it a JBOD or just a bunch of disks. Different terminologies, hybrid RAID, a couple different ways of referencing it. But basically it's using all the available space and then providing a RAID group either based on performance or redundancy. It's whichever you choose. And in my case, I will most likely choose protection. So I could handle the failure of one drive and, you know, go from there. So that's what I'm going to do. So as I finish up this last drive and I get this all set and put it in, the next video we'll actually do a discovery on it. We'll take a look at, you know, going through the wizard to find it, download the operating system that's needed for it, and, you know, format the drives and actually get the unit up and running. So I want to thank you. Again, my name is Brian Kirsch and this is Storage. Thank you.